Greetings, and I hope you're doing great. So this screencast set of slides represents the fifth of five presentations that I put together, and I've got to say, from my end, it's a little bit bittersweet. So anyway, as you can see, we're going to shift away from discussions of essential elements and focus on the smallest soil particles that we find in the soil environment, and they're called colloids, and they'll be defined in the coming slides. So we'll focus specifically on colloids, and we'll talk about the properties of colloids initially, and then move into the four main groups of colloids, which you can see here: phyllosilicates, iron aluminum oxides, non-crystalline aluminosilicates or amorphous aluminosilicates, and organic matter. So the properties of colloids are pretty straightforward, and they kind of rely on the fact that they are tiny. So these are particles that are less than 0.001 millimeter in diameter, and if you remember that your thumbnail thickness, if you kind of look at it in front of you, it's about 1 millimeter or so thick. The colloidal particles are 1,000 times smaller than that. So, of course, then they're going to have very high specific surface areas, and all the things that go along with having very high specific surface area, one of which is that when they're suspended in a liquid, they're going to stay suspended. That is to say that gravity will never settle them out. Another property is that they can be inorganic or organic. And something that's inorganic is not composed mostly of carbon, and of course something that is organic is composed of lots of carbon, and that is that carbon is linked to one carbon and another carbon and another carbon and so forth. And then another key feature is that colloids have a charge associated with them, and most commonly that charge is negative. So that since you have a negatively charged colloid, and that is going to attract cations, like the cations that we talked about when we were talking about the forms of some of our plant essential nutrients. So this discussion here is mostly focusing on objective number 4, and then also part of objective number 5. That is to say that we're just going to focus on this first sentence associated with objective 5. I didn't really do a very good job of circling that, but you get the idea. We'll talk about the second half of objective number 5 later. So there's 4 main groups of colloids, and the first group is called a group of phyllosilicates, and we will go into more detail later in terms of what a phyllosilicate actually looks like. But these are colloids that are found largely in temperate region soils. They're largely also composed of aluminosilicates, and we would find them, of course, in our moderately old soil orders like mollisols or vertisols, in some cases alphasols, in soils like that. So the soil that you're looking at right here, of course, is a mollisol, and then in the BT horizon of that mollisol, or in the BT horizons of the soil, is where you'd find a lot of phyllosilicates. Here's an example of what we call an electron microscopic view of a typical phyllosilicate. Not that it's super critical at this point, but this is a picture of kaolinite. And a phyllosilicate, the definition of what that is phyllo means leaf or flat-like shape, and silicate, of course, is something that's composed of silicon and oxygen. So they're leaf-like structures composed largely of silicates, and so that's what you see here with this example of a phyllosilicate. And from one side of the slide to the other, you're looking at 3 micrometers or 0.003 millimeters. And here's another example of phyllosilicate. This one is called montmorillonite. We will talk more about this one later, but you can see that this one has quite a bit more surface area, a lot more wavy features to the structure than the last one did. And we'll talk about why that is later. Here is an example of a technician working on an electron micrograph, and as you can see, right, it's a pretty joyous experience to get these types of images. And I got to do a little bit of work on this when I was getting my doctorate at the University of Florida, and you can imagine the smile on my face the whole time that I was working on this kind of equipment. It's cool stuff. So here's another example of phyllosilicate, a colloid, and these are iron and aluminum oxides, and we've talked quite a bit already about iron and aluminum oxides, but we already know that we find them mostly in more weathered environments. And so in this BT horizon over here, that would be our candic BT, and that's going to be composed of the types of tiny soil particles that are, we can say a little bit less reactive than our aluminosilicates. Here's another example here in these BO horizons here in this oxisol. This is also where we're going to find some examples, or they're going to be largely composed of our iron and aluminum oxide colloidal sized particles. So here's an electron micrograph of an aluminum oxide. This is called gibbsite. Not super crucial for our purposes, but just to add, a little bit of flavor to the discussion. So you can see that the structures here are quite a bit different than what we saw with the phyllosilicates in the previous examples of colloidal sized particles. Amorphous aluminosilicates represent our third example of colloidal sized particles, and these are the types of colloids that we find associated in andisols. So they're mostly derived from ash. They're super tiny, super high specific surface area, and therefore extremely reactive. And all amorphous means is that it doesn't have a regular repeating structure like a crystalline aluminosilicate would. So phyllosilicates, the first example of colloids that we saw, those are crystalline aluminosilicates, and amorphous ones are just less regular structures. So we don't necessarily have the same types of electron microscopic views of them. So you can see that this structure is much less regular, much less uniform than we saw in our examples of iron and aluminum oxides, or even the example of phyllosilicates earlier on. Our fourth and final group of colloids is organic matter. And organic matter, of course, is found in all soils, especially on the surface, but most specifically in histosols. And organic matter is also an amorphous type of material. That is to say, it doesn't have a crystalline structure. It doesn't have like a regular repeating structure associated with it. And so here is an electron micrograph of some soil organic matter, and as you can see, right, it's very high specific surface area, and also the structure is not uniform like we saw with phyllosilicates. So that concludes our discussion of the main types of colloidal sized particles, and we will drink a lot more deeply of this cup, especially as pertains to the phyllosilicates, as those are the most common colloidal sized particles that we find in temperature